not just leave it as piercing, then okay. All right, so we have the correlation matrix here. We have BMI and BMI is 1, BMI and glucose is negative. That means the higher the BMI, the lower the glucose. The higher the glucose, the lower the BMI. It might not be applicable in real life. This is an hypothetical data. All right, so BMI and glucose posts is now positive, but also weak. The piercing correlation is weak, 0.017, and not significant. The relationship between BMI and glucose pre is negative, weak, but significant because it's less than 0.05. All right, so the piercing correlation for between glucose pre and glucose posts is also very weak. They are not related at all, and it is not significant. All right, so piercing correlation usually is between -1 and +1. As the number tends to 0, from plus or minus 0.5 to 0, as it tends to 0, as it moves closer to 0, then we say it is weak. It has a weak positive or negative correlation, depending on what the signs you have, either negative or positive. On the other hand, if it's tending towards 1, 0.6 towards 1, we say it is strong. If it is 1, then it is perfect correlation. If it is 0, no correlation. All right, so whether significant or not is another thing. All right, significance just means that if we perform this experiment 100 times, 95% of the time we would still have this result. This result can be expected. All right, so that's piercing correlation, and the next is multiple regression. Now, predict post-treatment glucose level based on age, BMI, and pre-treatment glucose level. We want to predict post-treatment glucose level. All right, so let's go analyze regression, linear regression. So what are we predicting? That's the dependent variable. Post-treatment glucose level, glucose post comes to the dependent variable, while age, BMI, and pre-treatment glucose level, So if we know the age of a person, the person's BMI, and the glucose level before taking the test, can we, or are we going to be able to predict what the glucose level will be after taking the intervention, the treatments? That is what this is about. All right, so statistics, let's take descriptives, and okay, this is fine. Plots, just pick histogram and normality. All right, I think that's fine, right? That's fine. That's more than enough. So let's see the model summary. The model summary, because it is multiple regression, we are focusing on adjusted R square. So here we have minus 0.003. This is not so good model, in the sense that if we make this a percentage, we are saying that all these independent variables, when applied, they jointly affect or influence or predict about 0.3% of post glucose level. Yeah, so that's really small, almost zero. That means they don't have the predictive power of these three independent variables, are not much. It's almost not there. Like, it is absolutely, in fact, not there, because when something is 0.3 percentage, then that's almost 0% or 0% approximately. So now, looking at this, is this model good? Is this model fit? And the ANOVA table is telling us no, because you can see the sig here. The sig value is not less than 0.05, so it's a bad model. We will still report it, that it is not sufficient to predict then we'll give suggestions for why it is not sufficient to predict, and the other variables that might be able to predict. Now let's try something. Let's try to add more 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 variables. If this is glucose pre age, BMI, glucose pre, we don't need glucose pre twice. Okay, cholesterol pre, cholesterol posts, and okay, that's all. And let's see if there'll be a difference. Where are you? Okay, here again, no difference. You can see a little bit increase in their predictive power, but still no difference. It is not significant. 0.78. It is not significant at all. So we can't predict, although we know that the treatment, looking at all the analysis we've done, we can say that although we know that treatments A and B are good, like they give results, they significantly reduce glucose level and cholesterol level, but we cannot predict how well they would work. We are not able to predict how well these treatments will work. All right, so to save the output file, just click on the diskette, or you go to file and click save. Desktop, I'm going to save it in the free symposium, so I'll just call it outputs, and that's okay. Then don't forget to save your data as well. You can close your data once you are done, yeah, and save. All right, so before we save, to report them, you can just copy and then paste in your Microsoft Word. Then you can do the editing, or your Excel, you can do the editing anyhow you would like to. All right, so you can close that. So if there are any questions, you can ask, and preferably in the class, the SPSS class coming up, I would like to see you there. And can follow us on social media, Quiver Analytics, and it's going to be a great time. Thank you. I hope you enjoyed this. You can watch it over and over again. Don't forget to give us a like and a subscription. Just click subscribe, and we'll see you next time when the Biotoxcs group calls. All right, thank you, and bye for now.